Imagine a massive physical shipping vessel, hundreds of meters long, packed with thousands of containers, just sitting entirely idle in a port. Just sitting there.
Right. Doing absolutely nothing.
Exactly. And for every single day that vessel is delayed, it triggers over 50,000 euros in daily demerage penalties.
Ouch.
50,000? Yeah, 50,000 euros just evaporating into thin air because of, like, a scheduling glitch. Now, imagine preventing that massive financial leak entirely, not with a human frantically making phone calls across 7 different departments, but with a team of AI agents.
Agents actively negotiating with each other.
Right, in milliseconds, just rerouting cranes, updating customs, clearing the dock before anyone even realizes there was a problem. So let's unpack this today because we are looking at the MIT 2025 AI Index report. And it says 67% of enterprise AI projects are no longer just standalone models.
No, they're not. They are full teams of specialized agents working together, which, it represents a massive pivot in how we're deploying intelligence right now.
It really does.
If you're a business leader or a CTO or, a developer trying to navigate the enterprise landscape in 2026, you've definitely felt the whiplash of this transition.
Oh, absolutely. The whiplash is real.
Because just last year, in 2025, Gartner placed Agentic AI firmly in what they call the trough of disillusionment.
Right, the classic trough. Everyone thought it was just a buzzword.
Exactly. The consensus was it was just another Silicon Valley hype cycle that couldn't survive contact with the real world. But right now, we are actively exiting that trough. We're climbing the slope of enlightenment. And the financial projections are staggering.
How staggering are we talking?
They're pointing to a massive $15.7 billion in enterprise value generated by these systems by 2028.
Wow. Okay, $15.7 billion. So the mission of our deep dive into these sources today is to figure out the mechanics behind that massive leap. Like, how did multi-agent orchestration go from a risky theoretical concept to an absolute boardroom necessity in just 12 months?
It's been incredibly fast.
It has. And to pull back the curtain on this, we're using a massive, high-stakes, real-world deployment at the port of Rotterdam as our guide. We'll explore the underlying architecture, the surprising cost dynamics, and the strict European regulations that are actually shaping how this tech gets built.
And the port of Rotterdam provides just a perfect lens for this, because it really highlights the fundamental tech shift occurring across all major industries right now.
This shift away from the single model.
Exactly. Enterprises are actively abandoning the single monolithic AI model in favor of multi-agent systems. In high-risk, deeply complex physical environments, a single model just quickly hits a hard ceiling.
For both performance and reliability, right?
Right. A single large language model just cannot hold all the necessary operational context, maintain real-time awareness, and, execute flawlessly across multiple different functional domains simultaneously.
Yeah, I always look at traditional monolithic AI like a brilliant but entirely erratic solo genius.
That's a great way to put it.
You give them one task, say, drafting an email or summarizing a document, and they do it brilliantly. But the moment you overload that solo genius with 7 different, highly complex tasks at once...
Like checking regulatory customs and routing physical truck.
Right, or calculating tariffs and managing billing, they just completely freeze up. Or, worse, they start making things up.
That hallucinate.
Exactly. But multi-agent orchestration shifts that paradigm entirely. It's much more like assembling a highly disciplined corporate board. Everyone sitting at the table has one specific job, one area of absolute domain expertise, and they know the precise protocols for communicating with each other.
I love that visualization. The corporate board captures the intent perfectly. But let's be real, getting that board to function efficiently without it turning into a chaotic, overlapping shouting match.
Yeah, a nightmare.
It requires incredible architectural rigor. And the sources point to 2 foundational technologies that make this reliable at an enterprise scale, RAG and MCP.
Okay, let's start with RAG, Retrieval Augmented Generation. We hear RAG thrown around in almost every AI conversation lately.
We do, yeah.
But reading through these deployment notes in this specific context, it's not just a feature to improve search. It is the fundamental safety net.
It absolutely is.
It grounds the AI in absolute reality to prevent those catastrophic hallucinations. Because, in global logistics, an AI hallucinating a cleared customs form isn't just a quirky error.
No, it's a massive legal liability.
Right. It stops a supply chain cold.
It's the literal difference between generating text and making a verified decision. So RAG is what anchors the agent's reasoning directly to proprietary verified knowledge bases.
And there's actual data to back this up, right?
Yeah, Microsoft's 2025 AI reliability benchmark actually quantified this mechanism. They found that RGAG augmented agents hit an 89% accuracy rate in domain-specific operational decisions.
89%. Wow.
Right, and that's compared to just 62% for baseline models trying to rely on their pre-trained weights.
Jumping from 62% to 89% accuracy, that is the literal difference between a system you can confidently deploy and a system you just have to scrap.
Exactly. And RGAG achieves that through a three-layer mechanism. First, retrieval, which is conducting a semantic search across a company's internal documents.
Okay.
Second, augmentation, so taking that retrieved context and embedding it directly into the agent's prompt. And third, generation, where the agent makes an inference based strictly on that verified data rather than guessing.
That makes sense.
But for a massive decentralized entity like a port authority, standard ARG isn't enough. They have to rely on a mechanism called federated ARG.
Federated ARG. Okay, so I assume that means the enterprise data isn't just dumped into one giant, vulnerable central database for the AI to sift through?
That's the core of it, yes. Federated ARG allows these specialized agents to query deeply siloed, distributed databases.
Oh, I see.
So the customs records might sit on one server, the physical equipment status on another, and the weather forecasts on a third. Federated RV sends the query to where the data lives rather than moving the data to the query.
I get it. It's like sending a highly vetted investigator into a secure, locked room. They are allowed to go in, read the specific sensitive document, and report back only the summary of what they found to the corporate board.
Precisely.
You never have to copy the entire filing cabinet and move it into the boardroom. That preserves data sovereignty, which is absolutely crucial for European enterprises.
It's a non-negotiable.
Right, while still allowing the AI agents to make highly coordinated, informed decisions.
And once those agents have that verified information, they need a way to act on it.
Mm-hmm.
So if RA dictates how they know things, MCP, the Model Context Protocol, dictates how they actually execute actions.
The execution layer.
Yeah. MCP acts as the standardized language that allows these autonomous agents to securely interface with legacy software tools.
Okay, I want to push back on this slightly, or at least get some clarity, because this is where IT departments usually panic.
Oh, for sure.
How exactly does an AI seamlessly talk to a legacy system? Because usually, connecting modern software to an older system requires a development team spending months building custom, brittle API integrations for every single tool. How does MCP bypass that?
It bypasses it through standardization. Instead of building a custom bridge for every single application, MCP provides a universal translator plug.
A universal translator.
Yeah. It enforces a highly structured request and response model. The agent sends an intent in a standardized format, and the MCP server translates that into the specific query the legacy system understands. It enforces determinism.
So an agent can pull data from a 1990s legacy mainframe managing ship manifests, a modern cloud database handling finance, and a physical IoT sensor on a crane, all using the exact same unified protocol.
Exactly, without needing to know the underlying code of those systems.
That is wild.
It significantly reduces the edge cases that normally break automated systems. Because the protocol is strictly defined, the agents cannot receive unexpected, weirdly shaped data back from a legacy system that might confuse them and cause a hallucination.
Okay, I'm going to put on my skeptical CTO hat for a minute.
Go for it.
Because I'm listening to this architectural breakdown and I'm hearing about a RAG, 3 layers of retrieval, federated databases scattered across secure servers, and universal MCP translators talking to legacy mainframes.
It sounds like a lot.
It sounds incredibly heavy. On paper, it's elegant, but in practice, it sounds like a recipe for a sluggish, overly complex system that's going to crash the moment it faces a real-world, time-sensitive crisis. How does this actually survive contact with reality?
It's a fair question.
Yeah.
To answer that, we really need to move away from the abstract architecture and look at the concrete reality of the Port of Rotterdam deployment.
Let's do it.
We're talking about Europe's busiest port.
Yeah.
The scale here is difficult to overstate. They handle over 470 million tons of cargo annually.
And I was reading through the operational notes from their 2025 setup, and the nightmare they were living in completely proves your point about the solo AI model, or even human teams failing at scale.
Oh, completely.
They had disconnected systems across 7 different siloed departments. Manual coordination across those departments took 36 hours of throughput latency. Wait, manual coordination took 36 hours?
Yes.
How were they even managing that before? Was it just humans frantically updating spreadsheets and calling each other while a ship sat in the harbor?
Pretty much. It was a highly manual, highly vulnerable cascade. If a single vessel was delayed by weather, it caused a massive ripple effect. You'd miss your berth slot, the allocated cranes were left standing idle, the customs queue backed up.
And you'd immediately hit that €50,000 daily demerage penalty you mentioned at the start.
Exactly. The latency in simply communicating the delay across 7 departments was the core bottleneck.
Which explains why they brought in AetherLink. They utilized a platform called AetherDev to deploy a custom multi-agent ecosystem. They completely abandoned the idea of one massive AI brain and instead deployed a highly specialized 7-agent system.
Let's look at this corporate board they assembled.
Yeah. You have a customs agent checking manifests against regulations via RG, a logistics agent optimizing the actual container routing, an equipment agent managing the physical cranes, a vessel agent communicating with the ship operators, a compliance agent ensuring every single move follows the EU AI Act, a finance agent calculating costs and penalties in real time.
That's 6.
And finally, sitting in the middle of all of this, the orchestrator agent.
And the orchestrator is the critical innovation there. Notice that it is not doing any of the specific functional tasks.
Right, it's not checking customs.
Yo. Its sole purpose is to manage the relationships, timing, and conflicts between the specialized agents.
Let's dissect exactly how that conflict resolution works, because that's where the magic seems to happen. Imagine a scenario where the customs agent suddenly flags a container for carrying a restricted hazardous material.
Okay, a standard crisis.
In the old system, that halts the entire line. The crane waits, the truck waits, the ship is stuck. But in this multi-agent system, how does the orchestrator mathematically resolve that without a human stepping in to referee?
Well, when the customs agent flags the container, it instantly broadcasts a delay protocol. The orchestrator receives that signal and immediately runs a multi-objective optimization across the other agents.
Multi-objective.
Right. It queries the finance agent to understand the exact cost of leaving a crane idle for the next hour. Simultaneously, it queries the logistics agent to find the next available cleared container on the manifest.
So it's weighing the penalty of the delay against the cost of shifting the equipment out of sequence.
Within milliseconds. If the mathematical utility moving a different container is higher than the cost of waiting, the orchestrator issues a direct, standardized MCP command to the equipment agent.
To immediately reallocate the physical cranes to the new container.
Exactly, while the customs agent continues to process the flagged item. It's fluid, parallel processing.
And the hard numbers from this specific AetherLink deployment prove that this isn't just theoretical fluidity. After a 6-month run, the average vessel processing time plummeted from 36 hours down to just 19 hours.
That is massive.
It's a 47% increase in operational efficiency.
Achieving a 47% efficiency gain at a scale of 470 million tons translates to massive financial leverage. The system yielded €2.8 million in direct annual operational savings.
Wow.
It completely paid for its own development and deployment in just 8.5 months. Furthermore, the agent reliability, meaning the system didn't crash, enter a loop, or require emergency human intervention, hit 99.7% uptime.
Those numbers are a CTO's dream. But if you're evaluating this for your own enterprise, we have to talk about the friction points. Because saving millions in demerage penalties is great, but my immediate thought when you say 7 AI models talking to each other and running optimization calculations in the background, 24/7.
Is the API bill?
Yes. Every single time an AI thinks, reasons, or speaks, you are paying for token consumption. If I have an entire ecosystem of agents constantly chattering, isn't my token cost going to absolutely explode and wipe out those operational savings?
The sources explicitly validate that anxiety. In fact, early deployments of these orchestrations did exactly that. They completely blew out their operational budgets.
I knew it.
Yeah. Rotterdam initially tried deploying a single central orchestrator coordinating 10 subservient agents, and the token consumption was astronomical. The breakthrough that solved this is called agent mesh architecture.
Agent mesh. Okay, how does changing the topology stop the financial bleeding?
It comes down to eliminating bottlenecks. In a hierarchical setup, which is the default for most early designs, you have a central boss agent. Every single piece of information, no matter how trivial, has to flow up to the boss and back down to the workers.
Okay, I see where this is going.
It duplicates reasoning steps. If the logistics agent needs a simple status update from the equipment agent, it has to explain the whole context to the orchestrator, which then queries the equipment agent, processes the answer, and sends it back. That requires massive token usage for a simple query.
It's the exact same problem as a rigid corporate bureaucracy.
Precisely.
You have two interns, the logistics agent and the equipment agent. In a hierarchical system, if an intern wants to ask another intern a basic question about a project, they have to draft a formal email to the vice president,
Who then emails the other intern.
gathers the response, and emails it back down. It's an incredible waste of time and resources. So a peer-to-peer mesh architecture changes that by just letting the interns talk directly at the water cooler.
That analogy hits the underlying mechanism perfectly. The mesh allows specialized agents to communicate directly via those standardized protocols when appropriate, completely bypassing the central orchestrator unless there's a complex cross-domain conflict that actually requires mediation.
That makes so much sense.
The data shows this peer-to-peer routing reduces intermediate reasoning steps by 43%.
Which directly cuts your API costs by nearly half.
Yep.
I was actually reading the 2025 McKinsey study included in our notes, and the numbers stopped me in my tracks. They found that optimized multi-agent deployments actually cost 2.3 times less to operate than equivalent monolithic systems once you span more than 5 functional domains.
It's a wild counterintuitive fact.
More individual AI agents actually equal lower operating costs because they are perfectly specialized and taking fewer, highly targeted steps.
And the Rotterdam data reflects that exactly. Their mesh system averaged just 2.1 decision steps per container, compared to an estimated 6.3 manual steps in their previous operations. It's really lean execution.
Okay, so the mesh architecture stops the CFO from panicking over the API token bill. But if you are a European business leader listening right now, you have another executive to worry about, the chief legal officer.
Oh, yes.
Because saving money doesn't matter if the system violates the law, which transitions us to the massive regulatory elephant in the room, the EU AI Act.
Right.
Yeah.
Because you cannot just let a network of AI agents loose to optimize physical supply chains however they see fit in Europe.
No, you absolutely cannot. The EU AI Act explicitly classifies supply chain automation and critical infrastructure, like port operations, as high-risk deployments.
High risk.
Yes. And that high-risk classification means European enterprises cannot afford black box decisions. If an AI system decides to hold a ship at the dock or reallocate a massive physical crane, you have to be able to prove to a human or regulator exactly why it made that specific decision. You need an immutable audit trail.
Right.
This is where the concept of deterministic guardrails becomes non-negotiable.
Deterministic guardrails. Okay, I want to challenge this concept for a second. If we are paying for this brilliant adaptive AI system and then we put it in a highly rigid sandbox with hard-coded rules, are we just neutering the very intelligence we paid for?
Is that a common concern?
Doesn't the deterministic guardrail just turn it back into a basic rules-based software program? I get that, but it misunderstands the division of labor within the system. The guardrails do not limit how the AI reasons about a problem. They strictly limit what actions it is authorized to execute.
Ah, okay. Execution versus reasoning.
Right. The intelligence is used for understanding the complex variables, but the execution must fall within safe boundaries. It transforms an unpredictable AI tool into a certified auditable system. For example, at Rotterdam, they hard-coded a deterministic rule that no agent could ever authorize a physical berth release without explicit verified clearance from the compliance agent.
So the AI can optimize the schedule all at once, but it physically cannot override that security checkpoint. The guardrails act as the absolute unbreakable law.
Exactly.
And the sources highlight that platforms like AetherLink's EtherDev are building these audit trails and guardrails into the foundation of the agents from day one. Which makes sense because trying to retrofit EU compliance onto a wild, unconstrained AI system after it's already running your port is basically impossible.
Integrating that level of EU compliance does add friction, though. The data shows it adds about 12 to 18% in upfront development costs to a project.
That's a significant chunk.
It is, but you have to weigh that against what it prevents. Non-compliance under the EU AI Act for a high-risk system can result in regulatory penalties of up to 6% of your global revenue.
6% of global revenue for a multinational logistics company, that is a company-ending fine.
So that's 12 to 18% upfront investment isn't a burden. It's a necessary insurance policy. Furthermore, by using a platform with pre-configured compliance templates rather than building from scratch, enterprises are seeing drastically reduced deployment times. Rotterdam actually went from a projected 6-month deployment timeline down to just 8 to 10 weeks to get into production.
Just 8 to 10 weeks? That's incredible. All right, let's zoom out and distill all of this. If you are listening to this right now and trying to build out a resilient enterprise AI strategy for the rest of 2026, we've covered a lot of ground today.
We really have.
We've looked at the fundamental transition from erratic solo models to disciplined multi-agent teams. We unpacked the heavy lifting architecture of federated ARGRI and MCP universal translators. We explored the massive operational success at Port Rotterdam, and we navigated the realities of mesh token costs and EU guardrails. So what is the absolute #1 takeaway you want our listeners to walk away with?
For me, the single most important insight here is the financial and strategic viability of the agent mesh architecture. The true competitive advantage in 2026 isn't about which underlying foundation model you're using, whether you plug in Claude, GPT-4o, or an open source model.
Right, those are just tools.
Exactly. Those models are increasingly competing on per-token pricing and becoming commoditized intelligence layers. The real moat, the actual proprietary advantage for your business, is how intelligently you orchestrate specialized models to reduce overhead. If you can build a peer-to-peer mesh that resolves operational conflicts 2.3 times cheaper than your competitor's hierarchical system, you hold a massive structural advantage.
The power is in the structure of the team, not just the raw intelligence of the individual models.
Precisely.
Well, my #1 takeaway builds directly on that idea of structure. It is this concept of constrained autonomy. We spent so much of 2024 and 2025 obsessed with making AI as open-ended, general, and unbounded as possible.
Oh, everyone wanted artificial general intelligence.
Right. But enterprise agentic AI actually succeeds by doing the exact opposite. It thrives not by giving the AI total freedom to reinvent your business processes, but by placing it in a highly structured, deterministic sandbox where it is safe to be brilliant at one specific task. The guardrails aren't holding the AI back. They are the exact mechanism that allows the enterprise to trust it enough to actually deploy it into the physical world.
It is the only proven methodology to scale these systems out of the trough of disillusionment and into measurable boardroom-level productivity.
Which leaves me with one final, slightly provocative thought for you to ponder as you evaluate your own systems. In Rotterdam right now, we have an ecosystem of AI agents successfully negotiating with each other to manage physical ships, massive cranes, and millions of euros in supply chain value.
Happening today.
And as we discussed, the architecture is rapidly moving toward these peer-to-peer mesh networks to lower costs. So what happens when your company's AI agents start negotiating directly with your supplier's AI agents across corporate boundaries in real time?
That's where things get wild.
If an entire supply chain consists of agents optimizing costs and adjusting smart contracts in milliseconds without human intervention, where exactly does human corporate strategy end and automated negotiation begin?
It is a fascinating and rapidly approaching frontier.
And it all starts with mastering that first local deployment, that first container moved by a corporate board of algorithms. For more AI insights, visit etherlink.ai.